Okay, so it's Dr. Eng here. It looks like we're looking at beams today. So, so for this structure, which is laterally loaded, we will be calculating the sum of the force components in the x direction. Secondly, we would be calculating the sum of the force components in the y direction. And finally, we'll also be calculating the sum of the moments about point A. So the first thing we would do for this particular problem, we would start by drawing a free body diagram. The purpose of this diagram is to understand the nature of the forces acting upon the structure and how they behave. This is essential for any problem that deals with looking at beams. Often these sort of problems can also get complex, and you could be working with UDLs instead of point loads. So therefore, it's highly recommended that you draw a free body diagram prior to attempting this question. So the body diagram. Okay, so for this particular question, we would obviously need to remove the struts. The struts, the type of support which is holding the beam, it could be known as a strut. Ideally, there'll be some loads. Once we've removed the support, we would be required to add to this particular problem. So I'll start by naming this YB. The force is going up vertically, and then we've got force heading in the X direction. You're probably going to ask yourself, how do I know where to put the force? Typically, depending on the type of strut, the force and the way it would be applied to a beam problem, it's already predefined, so it's something that you can look up. So next, there's a length of 0.8 meters. Yep. And then we've got a moment of 8 kilonewton meters. And then from that point, we've got a distance of 0.4 meters. And then we've got a point load of 20 kilonewtons. And then a distance from the point load to the end of the beam or structure, or whatever you want to call it, of 0.8 meters. 0.8 meters. So we've also got the roller we need to remove. That's the roller. That's the name of this particular type of support. We would then remove that, and that would then have a force of YA. The reason why it's called YA simply because this point here is called A, and that point on the other side is called point B, and then it's just easier to name the supports after the X and Y direction. So if we were to work out the sum of the force components in the X direction, we know the sum of the force in the X direction. So if we look in the X direction, we can see that the only force heading in the x direction is xb. So we know the sum of the forces in the x direction equals xb. Perfect. So now we're working out the sum of the forces in the y direction. A little bit more tricky as we're dealing with a couple more forces, but the same principles apply. So sum of the forces in the y direction, we've got YA, YB. So we do Y subscript A plus Y subscript B. That's the first part. And then we look at the other side and we've got a point load heading in the opposite, acting in the opposite direction. So minus 20. So that's then the formulae for or graphical representation of the forces acting upon in the y direction. So next we then work out the moment. As shown in the previous video, the moment is force times perpendicular distance. So the same principles apply. So in this case, we've got a force or point load heading down in the direction and pointing down. So we've got 20 multiply by 0.8, which is its perpendicular distance. And then we've got a moment also of -8. Do remember your sign convention. So if it's clockwise, it's negative. If it's anti-clockwise, it's positive. So then we then have the remaining force that we need to deal with is YB, and that's going to then be multiplied by the total length of this beam, which on this case would be 0.8 plus 0.4, which is 0.8 and 0.8, which is 0.16, and then 0.16 and 0.4, which would be 2. So then we would have negative. Okay, so then we have negative YB multiply by 2.0. Okay, so once we've then got this, we would then be able to solve to work out the necessary parameters we know for these particular questions, that the sum of the forces in the x direction due to equilibrium would equal 0. The sum of the forces in the y direction would equal 0, and the sum of the moments in the a direction would equal 0. So once we worked out this then gives xb as 0, yb as 4 kilonewtons, and ya as 16 kilonewtons. 16 kilonewtons. So I do hope that you've enjoyed working through this question alongside me. It was actually quite an interesting question, understanding how a beam is loaded and the problem definition on how to solve static equilibrium questions. So I do hope that this video has helped you in some way. Do like, share, and subscribe, and I'll see you for the next one.